Digital signals. The alternating signals we have discussed so far are continuous and smoothly changing in amplitude and able to adopt any level. They are termed analog signals. Normally, there is an upper limit to how big they can get, which depends on the circumstances. Digital signals can only adopt preset levels, normally two levels represented using combination of ones and zeros. Analog to digital converter, ADC or A to D. Show figure 3.12 shows the familiar picture of an analog signal. The amplitude of the signal for every moment in time has a value on the Y vertical axis. As time progresses, an analog to digital converter, ADC, samples the analog signal to give a string of numbers which we call a number stream. This is converted to series of on and off pulses called binary code, which can be transmitted. Here's the figure. Sampling and digitizing a sine wave. The values in time order are 4, 7, 6, 3, 1, 5, 7, 9, and 3 minuses. So this is the kind of thing we're having with DMR, D-star, and fusion. In the distant receiver, a digital to analog converter reverses the process and recreates the analog signal. There are two reasons for converting our analog signal to digital. Digital signals can be processed in a computing device using software. All the functions of an analog radio can be performed digitally, often to a higher standard. The recovering to a higher standard. The task being performed can be changed by updating the software, something not easily achieved in an analog system. The other reason is that the digital signals are much more tolerant of electrical noise, which may come from sparking in electric motors, mains, power cables, distant transmissions, and thunderstorms. A digital signal looks like a series of pulses similar to that of a square wave. If the digital signal is stronger than the noise and we know what signal levels to expect and can decide which one it is, the presence of the noise, that means we receive transmitted signal much more accurately. This is illustrated in figure 13. Recovering it intact. There is a small range of amplitudes where we are not sure whether the signal was a 1 or 0, but much larger ranges where we can be sure. Today this is very normal and is the process used by mobile phones downloading music and Wi-Fi connected to webcams for video signals. Unsurprisingly, amateurs are active in developing new technologies to improve the technology, extract signals that are weaker than the noise, reduce the bandwidth required, and thus achieve greater ranges. The quality of the digital signal is dependent on how accurate we measure the value of the analog signal. The implications of that are discussed in the intermediate and full license courses. Computing devices can process digital signals to extract more information than is usual with analog techniques. It is now possible to directly digitize received radio signals, filter out unwanted signals, and extract the information, demodulation, entirely in digital processing. This is discussed further in the receivers chapter. Please like and subscribe my channel. 7-3. Thanks for listening. All the best.